because this is the culmination, in essence, of over 20 years' work. So, and also I think it shows really the real benefits of industry and academia working together. So I first met Andy and Christine actually when they were working for a consumer packaged goods company, and way back in 2004 we were working with a large multinational organisation to consider how to move from a very localised supply chain structure where they had one factory supporting one end market to actually create a global supply chain infrastructure that could still serve over 170 end markets across the globe, but could do so with a global supply chain strategy. And at the heart of this, we understood that we needed to be able to balance demand and supply, and that in doing so, and to do that in a way that was as effective and as efficient as it could be, that we needed to understand how variable or how unpredictable the demand signals were, and then use buffer management, whether those buffers be information, time, or spare manufacturing capacity to help to enable flow. And in doing that, we could really start to optimize those end-to-end supply chains. So in 2004, this was great theory, but actually the problem was we didn't have either access to the data nor the data analytics tools to make this a reality. And roll forward probably another 10, 12 years, we started to work together. And that first piece of work, I was actually at one academic institution, Cranfield, and then roll forward another 10 years, I was at a different academic institution, WMG, and Andy had moved on to join a small SME that was developing, trying to develop a supply chain platform, SupplyVue, that could actually address some of those issues that we'd identified 10 years earlier, but now we actually had access to the data, and through SupplyVue, if we could develop it, the potential to supply chain analytics to make this thing work. And actually what we were able to do was to use some Innovate UK funding, in fact 2 grants, to basically help support the development of SupplyVue. And that relationship continued, and at the same time at WMG, through other supply chain initiatives, we built a really good relationship with Tata Steel. And also we're introduced to a really exciting little startup called Carbon Chain, who all seem to have different parts of the puzzle. Tata Steel obviously had a carbon intensive supply chain, not because they were necessarily doing anything worse than their competitors, but the nature of what they produce, steel, which is a feedstock to many other more upstream parts of the supply chain, such as automotive, aerospace, construction, meant that if you start considering it from an emissions perspective, they would always be seen to be, as a foundation industry, one of those that had a higher carbon footprint. But of course, it's not just their carbon footprint, they are providing the product that goes into those things that we all want to use as end consumers. And so when Made Smarter Innovation launched a call to look at how digital technologies could help support the future of manufacturing, and with one of those critical drivers being net zero, we were able to bring together those different players. The SupplyVue platform that had the potential to have a carbon element added to it, Tata Steel that had a genuine need and desire because of their sort of customer driven nature to think about how they could begin to integrate further upstream to introduce carbon into those cost, quality and service decisions that had historically been made. Carbon Chain, who had this ability to do carbon accounting, but hadn't necessarily fully integrated it into a supply chain context. And at that stage, Loughborough University, who as a business school that now has a strategy around progressing with purpose, actually tackling real world problems like how we achieve net zero, is right at the heart of everything that we do. And obviously Interact is also, it's the social science aspect of Made Smarter Innovation. It is the platform to actually help us turn those insights into actionable insights that can make a difference to the world. And that's why it really is my great pleasure to introduce this particular project, because what you'll see are real actionable insights, both in terms of a platform that you could use, but also through the insights that Clare will introduce, how you can actually use that platform in practice and some of the things that you might want to consider. So I'm now going to hand over. I think this is a tale of three parts. I'm going to hand over to Rodrigo, who was the Loughborough research fellow who actually worked alongside the other partners to provide the sort of academic underpinning, but also I think a lot of education and training so that everyone within the supply chain, within the project, understood what it was that we were trying to achieve. He'll kick off. I think he's then going to hand over to, let me get the order right, Andy, who'll explain a little bit about the platform, and then to Claire, who'll explain how it worked in practice, before Christine will give you a demonstration of how the platform actually works. And then hopefully at the end we'll have a little bit of time for Q&A, and you will all be as enamoured by SupplyVue as I am, CarbonVue as I am. So without further ado, I'll hand over to Rodrigo.
Okay, good afternoon, everyone. Thank you, Jan, for the introduction. My name is Rodrigo Carrasco. I was working at Loughborough University for 2 years, working specifically on this project with Tata, with SupplyVue, Carbon Chain, trying to develop CarbonVue as a platform. I was basically trying to provide the academic insights around supply chain and a lot of the theoretical concepts that as a group we have been working on and we are trying to include in the platform. So I am going to talk briefly about some of the theoretical concepts, what a productive supply chain should look like, some of the issues that appears, and some of the principles that are integrated in the tool to later see the more fancy stuff around how actually the software is going to work. So if we can move to the next slide. And I would like to start about talking about what is actually happening in businesses at the moment. I mean, in terms of supply chain, what are companies doing in the UK? And we can see, for example, Jaguar Land Rover looking into more advanced analytics to know whether it could avoid supply chain problems. IBM developing partnerships with another software company trying to explore artificial intelligence applications in supply chain. I mean, after ChatGPT appeared, there is like a race trying to develop artificial intelligence applications in supply chain and to know whether it could actually be applied or not. And at the bottom, we can see Siemens, which is a cable manufacturer operating in the UK too, promoting how it works with suppliers. And finally, Airbus revealing some stability in their supply chain, pointing out this as a good thing, as something that can enable them to operate better. So we can see companies trying to do something around analytics, AI, digital tools, collaborations, stability. So what does it mean? If we move to the next slide, in the end, companies are trying to, are looking for mechanisms to improve productivities. They are trying to maybe produce more with the same or with less input, or maybe trying to keep the output with less materials, trying to reduce waste, or identify where they can actually improve something in their operations in order to have better production outputs and consequently better financial results. From a theoretical point of view, what makes a supply chain productive? So if we move to the next slide, let's start with what is an unproductive supply chain, what we see from the theory as an unproductive supply chain. And this is something like when we have disconnected processes, when there is misalignment between the different areas. And we are not talking only misalignment with suppliers or customers, but also misalignments within the company. let's say some examples. If our own business is planning a 5-10% growth for the next following years, can my suppliers keep with that? If I am developing a new product, am I considering the inputs from my customer, from the supplier? Is it something that, I mean, is it a goal that we all share? So these specific details or this small stuff sometimes is not shared between all the participants in the supply chain, and it could generate issues. Is planning actually driving all the other functions like delivery, like manufacturing, like all the operations? Or is there a different plan for each area? Or maybe there is one plan, but usually they don't follow because I know I don't trust in the forecast for sales from sales. So maybe um, operations don't fulfill its plan. So these kind of problems generates misalignment in the supply chain and could generate um, different problems in each stage. And at the end, all of these, including the variability on the demand by itself, is what generates the what we call the bullwhip effect when um, it could be the inventory, it could be products, our cash flow, or either the information that goes up and down, and we are not on an unstable stage. What is a productive supply chain? A productive supply chain is exactly the opposite. When there is alignment in the plans, internally and externally, and we always think that supply chain planning is a function that can drive this behavior, is that one that is like the glue to align source, make, and delivery functions within your company and with all your customers and suppliers. Um, and the main is when we have share information, share goals, and also when there is like a stable flow with buffers in place, because in reality, we know that demand is variables. Our customers are always going to change their requirements. More or less, I mean, depending on the sector, depending on the business, variability could be less or more, but we always have variability um, in terms of demand and also in terms of supply with different shocks. Just to mention, a couple of years ago, the Suez Canal was blocked for 6 days and it generated a big impact. I mean, depending on the business, but it was a huge shock. So there are always going to be shocks, either from the demand side or from the supply side. And the idea is to keep the flow as stable as possible because this is going to generate a productive supply chain. If we talk about the mismatch in demand and supply, let's take one side first of all. What happens if demand is greater than supply? We're unable to get the things that we need. Customers are unhappy, and we actually run out of the things that we need. Think about the toilet rolls that happened at the start of the COVID pandemic when actually everyone was trying to buy it and there was not enough supply of. More recently, the chip shortage that is still affecting lots of companies and is generating a lot of variabilities in car manufacturers, in companies doing electronics and so on. So when demand is greater than supply, there is a problem. But if we go to the next slide, if supply is greater than demand, it's also a problem because it generates excess of stuff. The inventory needs to be kept somewhere. It could be at the end resulting waste, or it could become obsolete. Um, Imagine Apple not planning it correctly and supplying too many iPhones, which is not the case at the moment. But if a technological product is not planned properly, it's going to be waste at the end of its life. The demand and supply in an appropriate way. We're trying to follow two principles because, as I mentioned, variability is always going to be there, but there are two principles that we can follow in supply chain management, and one of them is the buffer management that we can keep to manage this variability, and the other is trying to establish flow using a segmentation approach, so we can define different strategies according to the different demand behavior. Let's start with the buffer management. We identify 3 buffers, as I mentioned: production, inventory, and time. And maybe the most popular is the one in the middle, inventory, because we always think that if we when we talk about buffers, we always think about safety stock, and this could cover fluctuations in demand and also fluctuations in water supply. But we can also use production capacity if we have the facility to increase or decrease our production according to the demand signal, or maybe we can use a third-party supplier to cover for any external increase in demand that we could have in the short term, or maybe decrease the shifts in case we already have the assets. But also we can talk about time as the lead time. And what happens if we can ask the customer to modify the lead time, maybe wait a bit more in case we have issues in our production. There is also a buffer that can help to alleviate some of the problems. And unfortunately, all of them involve money. I mean, it's a cost and sometimes not cheap, depending on the business, but it's actually the cost of being flexible. It's the cost of trying to react properly to changes in our supply chain. And it all depends on your demand signal, because as we can see at the bottom, if there is a stable demand, buffer size should be decreased. But if your demand is unpredictable, you need to have some buffer in place to deal with that. The second principle was about understanding the demand patterns through the adoption of demand profiling. And this is about segmenting your supply chain, trying to adopt different approaches to manage that. We can think about like the graph at the left about managing your demand as base and surge, like 80% that is always stable, and then just 20% that maybe it's variable with some peaks. Or maybe we can analyze our supply chain using demand profiling. This is an approach that um, in our group we have been using a lot for the case studies, and we're trying to measure the variability and repeatability of demand, establishing 4 segments: smooth, lumpy, erratic, and intermittent. And based on that, we can develop a tailored supply strategy. And the idea of segmenting your supply chain is to create a specific production strategy, a specific supply strategy to that product or to that group of products. We can move our decoupling point, our buffer along the supply chain to keep the change in the product maybe early or maybe late in the process. So let's talk about, for example, the buy to order approach. In this case, the inventory is basically going to be on raw materials. So in that way, we can react. We are just basically reacting to confirm orders from our customers. But in case of a make to stock, is something totally different. We usually keep the inventory as a finished good, and we can react to the demand faster than that. So again, it all depends on the context. It all depends on the business, on your demand profile. So as a summary right now, a productive supply chain is something that is stable, that is aligned, that try to use the correct buffers in place, and that it has different supply strategies based on the demand profile. We're trying to include all of this using the product wheel concept. That is basically a figure that we use to represent a repetitive sequence in production, in which each product has a specific slot in our scheduling. Even it has a specific slot, it doesn't mean the same quantity or the same frequency. Trying to match with the concept that I said a few minutes before. If there is a product that is made to stock, that is one of your runners, and it's always like you always have to produce it. It can be product A, in which you produce it every week with probably similar quantities. But there could be another products like GH that appear on the graph that maybe you are waiting for the order. In this case, you save the slot in your schedule until the order arrives, and you know that at that time of the day, at that time of your week, of your wheel, that it could be a week or any other period, you are going to produce that. Or maybe you could have another product that, due to the constraints with the minimum order quantity, one batch is enough for 2 weeks of demand, 3 weeks of demand. You know that in your sequence is going to be after product C or product D, for example, but it's not going to happen in every wheel, in every period. It's going to be with a different frequency. You're going to see a better example when we see the demonstration with the tool. And the advantage of this is that we have repeatability, stability in the supply chain. We know what's going to happen, even though the quantities could change. We can't talk about supply chains without mentioning sustainability. At the moment, it's a very hot topic. Everyone is talking about that. We know net zero is a legal target for 2050, so we need to do something, and supply chains actually can do a lot over there. So either by the energy that we use to produce the products, the transport use for goods and for the people at work, and how we treat the waste. There are different things that we can do in supply chains to achieve this net zero target, to be more sustainable. And in the next slide, you're going to see some statistics in which there has been a progress, but we are not yet. Okay, so those are statistics from the our work in data. This shows the CO2 emissions by sector in the United Kingdom. And there has been a progress. I mean, we have to be optimistic that we can do something. So CO2 emissions have decreased in the UK. This is data until 2019, but there is still a long journey before we can achieve net zero. And we can see transport, electricity, manufacturing as one of the main sectors that generate CO2 emissions, all of them related to supply chain. So actually, there is a lot we can do here. And in the next slide, we can't do anything about supply chain productivity or sustainability without data. And data is the new oil. It's actually a phrase said by Cliff Hamby back in 2006, almost 18 years ago. And there are still businesses that don't take full advantage of the use of data. As was said also, you can improve what you can measure. So we need to have a database approach for all the decision making. And now that we have ERP, sensors, CNC machines, we actually can do much more to that. Just to finish, because I think I have run out of time, can we actually increase productivity in a supply chain without losing the focus on the sustainability agenda? This is a question that we have been trying to work on for the last 2 years, in which, okay, we are trying to make a productive supply chain, but we need to include the impact of carbon. And to talk a bit more about that, I will pass over to Andy.
Thanks, Rodrigo. So what I'll do is basically taking the principles that Rodrigo has explained and show how we're realizing them in the software, but also how we're bringing together the best practice principles of running a supply chain and incorporating carbon objective management into that process as well. So firstly, the software platform we built.
Hold. Oh, there we go.
Okay.
Yeah.
So the CarbonVue product is it's a cloud-based piece of software. It ingests the data from a business's underlying systems. So it really we take all of the data you would expect you'd need to analyze a supply chain. So obviously you want the picture of the forward demand. So we take forecast information, we take actual sales information, we bring in inventory information, supply chain plans, schedules, and actual transactions that occur in the supply chain. And we bring in master data so that we can cut and slice and view the supply chain in different ways. So we're bringing in all of the data you'd need to analyze the supply chain. And the system has got inbuilt supply chain excellence assessment of the past performance of that supply chain. So we will assess the supply chain based on the principles that Rodrigo was talking about, and we're essentially looking for good product flow through the supply chain, making sure that that there's rapid flow, it's stable, and it's predictable. We'll look at the use of assets and see whether the assets are being highly utilized, and we'll look for buffers in the supply chain. Are there low buffers? Are there low inventory? Short lead time, short cycle times, no unnecessary planning buffers in the supply chain. And we'll also look for, is it a process-driven, data-driven supply chain, or is there lots of manual intervention in the process? So you're looking at the supply chain from all of those best practice characteristics, and then you can evaluate the performance. You can measure then what is the cost, what is the service provided by the supply chain, what is the cost of providing that supply chain, and what is the carbon cost of delivering the supply to the customers. And that can be your backward-looking baseline. And then the rest of the sort of the CarbonVue SupplyVue solution is then has got the modeling capability where you can start to model different policies. So we tend to optimize policy within the supply chain. And so what are your other alternative ways of setting the supply chain up? How will you process demand and product through the supply chain? Lot sizes, frequency of manufacturing things, where things are stored, and sources. So you can build different models and different scenarios of how you'd want to set that supply chain up, run those scenarios, evaluate those scenarios, and then out of that analysis will be your principles and policies about how you actually want to plan the supply chain. And those come as output policies that go into the network planner, and then the network planner will then plan the supply chain according to those policies. So some of the things that we'll go through on this call is that there are different lot sizes or different sources of where you make things will have an impact on whether you're a service-oriented supply chain. So maybe you're making smaller batches more frequently, to a cost optimized supply chain, or to a carbon optimized supply chain. But in the end, they'll come through as just different parameter settings in those same policies, and then the planner will run against those different settings, and you should then get the outcome that you expect. So that's the core platform that we built, and I'll just talk a little bit about some of the items within there one by one. So we've got the analytics that I've described. So we use this to, as I said, to carry out the assessment. We've got standard ways of analysing the supply chain, so we can do essentially almost a benchmark best practice analysis of the supply chain. We will look at the demand profiles and look at the quality of the demand planning and forecasting, and how predictable the demand pattern is onto the supply chain. And then we will look at the supply response to that and look at the planning policies, how synchronized the demand and supply is. Is the supply chain balanced? Is the supply capability balanced to the demand requirement? And then how well is that product flowing through the supply chain? So we will look at the product flow, the frequency of movement, and inventory is actually a key measure of flow. And so is it a low inventory supply chain where the inventory is efficient? You've got just enough, but not too much. So we have measures on efficiency, and we will do it based on normal demand segments. So you may have different measures of excellence, whether it's a smooth, high-running product compared to a sort of a more intermittent, less frequently ordered product. So the actual measures of how you measure those may well be different. And so that will form the basis of understanding how the current supply chain is set up, how well it's performing, and what policies are in place, or if any. Sometimes you'll find that really the supply chains are not really being managed against policies. People are having to process, and it's really a lot of firefighting going on. It's more transaction by transaction almost, management and execution of the supply chain. Oh, I think that was it. So that's the analytics. And then when you've understood the supply chain and the performance, you actually want to then say, can we model better ways of setting the supply chain up? And everything in SupplyVue and CarbonVue is really based on the principles of production wheel-based planning methodology. So the first thing you've got to do if you want to adopt that way of working is actually being able to design your production wheel, which Rodrigo was talking about. Now, this is actually quite a hard mathematical problem, and I've just got some examples there. I think I've got an example of if there are just 22 products on a production line, and the kind of natural cycle of those products based on the rate of sales and the minimum batch size puts them into categories of products that could be made every week, or products that could be made every 2 weeks, 4 weeks, or 8 weeks. That's how we construct our template. Then the number of possible combinations of that template becomes quite a high number quite rapidly with a number of products on the line. So I don't know what that number is, but the total number of combinations, but it's 562 somethings, very large number. And that's just with 22 products. And I think some of the lines that we've been modeling and solving have got hundreds of products on the production line. So it's actually a very large mathematical problem. And I think in the example I'm going to model, I've got about 27 or 30 products on the line. So it is actually, the little demo I'll do is actually solving quite a large problem. And then in designing the production wheel, this is where the sort of the different objective functions come in. You can select to design it for a service-oriented supply chain, which is basically saying what's the fastest wheel, meaning the smallest batches, and therefore you're making things the most frequently, given a constraint. And the constraint that we typically use is your hours available on that line. So if you use all of the hours available, how fast can I get product to flow through the supply chain? And then the other objective functions is a holistic cost objectives function, which is basically saying, well, there's actually various costs in supply chain I need to take into account. The key ones are probably associated with inventory holding costs, maybe even write-offs of inventory if you've got too much inventory, or costs associated with not having enough inventory, which could be extra logistics trips. So lots of costs you can take into account there, and also the manufacturing costs of changing over. So we take those costs into account, and the algorithm will work its way through and find a minimum cost answer that essentially is trading off between, say, changeover costs on the production line and the inventory holding costs. And then there's a similar algorithm which works in a very similar way to the cost one, which is the carbon optimization one. Yeah, so it will take into account carbon cost of a changeover, which could be the waste of the product when you're changing over from one product to another, and then the carbon implications of say inventory or stock tend to be damaged stock. So if you've got too much stock, you may damage it, or it will go out of shelf life. And then also if you've got too little stock, maybe you're again going to incur extra logistics energy because you're doing multiple drops where you could have done a full load and one delivery to a customer. So we can take those carbon impact costs into account. And again, the algorithm will find the sweet spot, whereas the frequency of manufacture that will give you the lowest holistic carbon. So that's the main mathematical problem that which we are solving in our solver. Wrong button. And I'll actually show you that. So the solver optimization part of the solution solves that production wheel problem, calculates the frequency of manufacture of the products, and then that template of your production wheel for your production, we then pass that to the inventory modeling. And then if you know that a product is made every week, you can calculate the associated inventory level for again a service objective. If it's every 2 weeks, then you will calculate the associated inventory with that. So in the end, when you've finished the modeling and selected how you want to set up each of your production lines in your factory, you'll get a set of policy parameters that will then be passed to the planning system. And then the planning system will then execute the plan against those policies. And then you should get your outcome that you're expecting from the modeling, but we will track that with the analytics. So we'll see whether you stick to that template, stick to that plan, and what is the outcome you want, which was the plan I was just talking about. So you pass those parameters to the planner, and then the network planning engine that we've got, planning solution we've got, takes the production wheel template, and it will plan the network respecting that template. So how the planner works, its first run, it takes the demand onto the supply chain and basically creates an unconstrained plan for each work center, but respecting the drumbeat of the templates. And then there's a plan solving set of capabilities where it will start to level the plan. So typically typical ways of solving a production plan are all inbuilt. You might say, we'll put on an extra shift so you can change the capacity, rerun the plan, see if that fits. You can bring inventory forward, and then there's rules about how far forward you can bring a product, but it will also only bring it forward into the weeks where that product is planned to be made according to the template. So when it's solving the plan, it will keep respecting the template. You can then, if you've still got problems, you may want to alter the quantity you're going to make. So maybe you will break a batch rule, make half a batch. That may buy you the ability to get underneath your capacity constraint. But then that might have consequences on your inventory levels, and the plan will highlight, okay, so if you have had to compromise on the quantity you're making, which products in which warehouses in which weeks have you potentially compromised the service level. So it gives the user the capability to solve the plan and see the consequences of the decisions they've made in solving that plan. And then in the end, you'll come up with a production plan you're happy with, which is then passed to the scheduling system. So we've got full planning capability. And the link to the carbon there is that your policies have already defined your carbon optimal supply chain. So if you've decided to optimize your supply chain based on carbon, the policies will already been built in, the frequency of manufacture or where something is being held, and the level of service you've built into the service to protect for, say, part loads. So that's already built in, and the planner will respect all of that. So in the end, this capability will create a synchronized drumbeat supply chain. It's very easy to understand. You know when things are meant to be made. You can see whether you're hitting the template, and you can see the demand placed onto the factory, and you can see the schedule going forward in time on when products are going to be made. So it gives you the ability to communicate with customers very clearly, because you know when stuff's going to be made, and you can see the plan consuming the forecast, delivering the, making what they should be made each week. So it's very easy to understand how the supply chain is performing and whether it's on track, and it will be leveled and feasible. And so that with all of the analytics, the modeling capability, put the modeling I've described and the planner together, and you can run what-if scenarios for different resource levels, different demand patterns, different demand profiles. And so it gives you the capability of some more strategic planning, what-if scenarios, as well as the more tactical decisions about what your policy should be in the next, say, 13 weeks or 17 weeks. So it gives you the full planning, decision-making, decision support capability, so that your supply chain becomes connected, data-driven, aligned across holistically aligned, synchronized. You've got the drumbeat, and you synchronize demand and supply. And the algorithms and rules will become more and more self-managing as you set the rules up to solve the problems. So I think over to you.
Yeah, thank you. Let me just I think I'm taking control there. Okay, so let me just move into our section. So, okay, my name's Claire Bailey. Lovely to have you all along this afternoon. I'm the project manager for the Carbon Vue project for Tata Steel UK, and I've been involved in the project for just over 2 years. And I've been working very closely with the part of the business this has been delivered into. So just wanted to give you a bit of a brief overview as to which part of our organisation we're talking about, just to give you an idea of the sort of business we're trying to implement the solution into. So where we've been really focusing our energy is in an area called the Distribution UK and I business. We have a site based in the West Midlands in a place called Wednesfield, and this is where we do processing of steel, which comes from some of our sister plants upstream in South Wales, and we convert it into a number of types of products. So slipped coil, sheets, blanks, tailor welded blanks, which are where we bring two pieces of steel together, and also plate profiles. And in some cases, we also process products such as aluminium to support other customers as well. And over that site, we've actually got 25 assets, which are servicing automotive engineering and retail sectors. And on the left there, you can see one of our production lines, which is supporting the automotive business. Okay, so that's the sort of organisation we've been looking to put this into. So hopefully you've got an idea of sort of size and scale we're talking about. And I think the comment that Andy made about the number of products, or the increase in products that we've challenged them with dealing with, has been quite one of the main factors that has contributed to the challenges of this project. In terms of giving a bit more understanding of where we have been in this part of the organisation, it's very clear that this part of the organisation hasn't seen so much of the technology in the past, and has had very inconsistent ways of working. A lot of custom and practice really in place, as opposed to best practice processes across the boards. A fair amount of gut feel being used to drive decision making, promptly used because data hasn't always been trusted. And a bit of a lumpy supply chain, really, with a number of different aspects affecting it. One of them being that the different parts of the supply chain haven't been so closely connected, which means that we end up with sort of lumps at the start and at the end of the process. Some lack of transparency around the data to drive that analytical solutioning, which means that we've been having to make decisions without necessarily having all the information in place. And also some lazy stock in the chain caused by sort of disruptions in some of the demand patterns coming through from customers. It's been quite difficult for us to actually optimise the supply chain using those lean principles, which we're looking to pick up with the future tooling that we're putting in. And also, really, the one that caught it for us was about this carbon impact piece, which we've been desperate to try and get up and running in our organisation, so we understand the impact of carbon. Our customers are asking for this. They want to know how the carbon footprint of the product that they're getting in is affected by what we do. So that's a really important piece for us. And I think the kicker there is really key. This is a big leap into the unknown for this particular part of the business, with new technology, new concepts, and also new ways of working. So really a big organisational change. So the approach we've taken to this project is first of all to have a Prince 2 Agile approach in terms of the way we manage it, to allow us to bring in some of the results quickly. And part of that is really to help us to get people in the business who are not used to this sort of thing on the hook straight away and understanding why it's important to change. And it also aids that change management process. We've also empowered specialists from the team across all the functions, including IT, to be involved from the start, which has really helped to break down some of those silo barriers that you can get in organisations and flush out some of the issues. I seem to be going on hold a fair amount today, which is not helpful. Can you still?
It's fine. It does seem to be.
It's still
The internet flashing in. Yeah.
Okay.
Okay, you're fine now.
Am I fine again now? Because mine's showing us still on hold.
No,
Sorry, I seem to be going on hold a bit. I'm back again. So, and also we've been using business readiness assessment to help us to understand where we've got gaps between where our business is and where we need to get to, so that we can change the ways the business culture is, as long as alongside all the IT that's going in. And then the first thing we really wanted to do to help with that was to surface the data through the analytics tool. Actually having the tool and being able to show the data to people helps to drive that challenge of getting the data quality right. And really to get that process discipline in place to help people to understand the role of data and how it's really vital to be able to use digital twins and this sort of technology going forward. So that was really the first piece we did, to understand what we had and to try and build that foundation, which is really critical to such a solution. And also to educate the business and get them to start thinking about why data is important and the role that they play within doing that. And then after we'd started doing that, we looked at, well, where could we implement the analytics to start driving decision making and make sure that we had some fit for purpose data we could use to give tangible results to our end users, particularly within the commercial space, but also within the supply chain area, and get them starting to think about how they could use the data in PDCA processes or in meetings with customers, and also to help them to understand some of the concepts and the ways of working and get familiar with them, so that when we move to bringing some of the other tooling in, they're already starting to get used to it. And then the other part of that was then the modelling and planning pieces that we've talked about, and really think about how can we get that in first. So which is the simplest area to look at? So we chose 2 particular production lines which don't have upstream assets that we need to be dependent on in order to create their plan, and start thinking about how can we make the tool drive some of the sorts of solutioning that we want to see, and think about how we can use that to practice carbon optimization as well as cost and service. And then as we go forward, and you'll see a bit later where we are in the plan, aligning the implementation rollout to the functional capability that was becoming available, because unlike other projects I've certainly been involved in, this was the first time I've seen a product being developed alongside the implementation in this way. So we've worked really closely with SupplyVue, and you probably noticed they're actually in the room with me today because we're having another one of our sessions to talk about how we can take the product further. And it's a really exciting thing to be involved in. And we're also learning every time we implement, so not just on our side about how to use the tool, but SupplyVue are going away and talking with Carbon Chain about how they can do things a bit differently, or what's the best way to approach a problem that might help us in making the future a really the product a really good future tool. I wanted to share with you the bit about carbon functionality. One of the things that, as I said, was the piece that really caught for us the reason why we wanted to work with SupplyVue and Carbon Chain. And also obviously with Loughborough on this piece of work, because it's something new, different, and something we really need in industry. And this is not something I've seen anywhere else. And so to work with an organisation like this and looking at those things was a really exciting challenge. And for us, it's important to understand how we can measure the carbon impact of the chain. Not something we've been able to do in the past, although we've been wanting to do it, and trying to understand, particularly with our routes into customers and the modes of transport we use, what's the best approach. And I think the one area that we were really excited by was particularly around uses of vessels. And that graph on the right there, you can see, is just an illustration of some of the insights we got when we started working, particularly with Carbon Chain, just to start looking at our data, where it was really clear that there were certain suppliers who had a much bigger footprint than there were for others, and that we hadn't even been able to see that in the past. So that was a really useful thing for us to start seeing. And to be able to then build that into a everyday decision-making process and think about how we could use that in terms of improving the way we operate and helping to give customers confidence in in the fact that their products are the greenest products they can find. It's one of the things that really enticed us into this and want to make us work further on it. So really being able to give ourselves that visibility, looking at the trade-offs between carbon, cost and service is something that is really key to us in this area, and looking at how we can support our zero carbon logistics policy that we're working towards. And then, as I said, when you look at the modelling, there are certain things that we would do to improve the way we operate by optimising inventory, improving flow and smoothing out our supply chain, optimising whether we're going by road or rail, thinking about different routes we can take, the yield on the product, maybe there's different batch sizes we can put in, maybe change the size of the product that's actually starting up in the process for slitting. And all of those actually have an impact on our carbon capability as well, but we're able to measure that now, rather than just thinking, oh well, if I do that, maybe it will improve the carbon. And that for us was also really useful. And as I said, then in terms of the planning, the improved planning capability also helps us to have better efficiencies, and therefore it has an impact on our carbon footprint. Now, we're really lucky in Tata Steel that we have a carbon emissions library, and we've spent several years developing that, but not many companies do. And if you look at the companies of sort of similar sized part of the organisation we've been working with, it's not really there. And as I said to you with the shipping piece, that was something we didn't have. And actually working with Carbon Chain has been hugely helpful for us to actually understand the art of the possible. And this is something that SupplyVue will be continuing to work on, and working with Carbon Chain. And it's that partnership that they have which really helps to drive such a useful piece of work for us, and actually bringing those two pieces of data together, both our elements but also the pieces that Carbon Chain can provide in the future as this product gets more mature, will be a really great source of data for us going forward. So please don't be frightened if you don't have something like that. You know, there is possibilities to make it happen. So just wanted to give you, as a final view, a bit of a flavour of where we've got to in the project. And you'll see the little yellow arrow on the top right hand side there where we are. We haven't fully deployed the system yet, but we've done a lot of work to get there. And I think it's fair to say that the biggest challenge we've had is data. And I think that's no big surprise really, but actually when you look at the amount of work that's taken place in the overall project, by just getting that data there so people can see it, understanding the problem statement of what we've got and trying to develop that, and then use the tooling to help us along the way and to drive the change in the way people think about data and how to use this type of tooling. That's been really key. And it's thanks to the team at SupplyVue in helping us to get that journey progressed. Where we've got to, we've managed to use the tools in a more of an MVP state, so minimum viable product, be able to prototype some of the solutions, look at how it impacts with carbon, and be able to demonstrate that to people. And we're now really getting into that practical side of, right, how do we really get this into everyday life within Tata Steel at the distribution part of our organisation, and roll it out in an iterative way, as I mentioned. So we're currently in a final element of data get fit, and we will be finishing off our business readiness activities before we really start to push and roll out the solution across a wider population. And that includes really understanding and making sure people are brought into those processes of management of change when it comes to new data, making sure people understand and respect what the tool is telling them, and then change their own behaviours to make sure that the inputs are correct, and then that drives a much better outcome. And by the end of this, we will have it as a fully embedded piece of activity within the team, and it will be driving a significant amount of decision making and work within that space. So that's where we are, and I really do believe that it will bring some significant value to this part of the organisation as we move forward. We're already seeing those green shoots as I described, and this is really the next step to taking us forward. So it's been a very successful piece of work from our point of view, and we're very much looking forward to working with the teams in the future. And I think that's basically it from me. Lovely.
Okay, so I'll go through this quite quickly, but see if I can explain what you're seeing. So this is the part of the tool that will calculate the production wheel. I'll just show the outputs first of all. So the way we calculate the wheel and the way we represent it is these columns represent each week. So we calculate a planning template with slots for each product over the next 8 weeks, and then if you want to go further, it's a repeating 8-week pattern. So the little blue slots are is a slot for the production of an SKU, and then the orange bit is the changeover time between that SKU and the next SKU. So the tool, in this case, it's the time-constrained algorithm here, is we've given it a capacity constraint saying there's 45 hours available on that production line every week, and we've allocated the products with their average sales rates to the production line. We've got a changeover matrix, which is the time taken, the cost of the time, cost, and the carbon cost of the changeover. And then it will calculate the optimal production wheel based on the different objective functions. So it'll calculate it on the fastest wheel, which means the most frequent manufacture of every product, given the time constraint, or it will calculate the holistic optimized wheel based on the costs we want to take into account, or it will calculate the carbon optimized wheel, again, based on the carbon impact. So with all modeling tools, you have a set of inputs that you can consider and then actually play around with, so you can run scenarios by changing those inputs. So if you're going to calculate the wheel on a production line, you allocate the SKUs to the wheel. So we've actually got, there's about 100 or so products on this line. I just picked about 27, I think, or something like that, products that I'm included in this run. So those are the products I'm going to do the modeling for, saying these are the products I want on that production line. It's got the sales rate of those products, which is the average weekly volume sold. You've got the production run rate, so when you're making that product, how many can you make in an hour? You've got the minimum order quantity for that SKU, and the minimum incremental quantity if you need to make in larger batches. And then for the products themselves, we can take into account a model around the format of that product, but we can use it to solve the problem, and the batch that's associated. So that's the actual product batch. So if you're making beer, that would be the lager. Say they're all lager, that's a particular lager, and you might have 10 SKUs, all with the same lager in, but they're into different bottle sizes or bottle formats. So all of those things are the inputs that we take into account, and what that will do. And then that's the output you're looking for. So one of the things that we run, first of all, just to explain some of these outputs, is the unconstrained template, which is basically saying if you make everything as frequently as the minimum order quantity allows, but make it with minimal changeover time, i.e. it's like you've got a traveling salesman problem as you're going through the going from one product to the product, can you minimize the changeovers? And if you level that plan across the week, so you've got a level loaded plan, therefore what is the fastest wheel you get? So with those products, I think so take into account, I think it's about 25 or 30 products on here. The cycle speed measure, which we'll use, and I'll use that to compare to different scenarios, is 1.48. So that means the sort of the volume weighted frequency of manufacture of the products is they're on average being made once every week and a half, 1.5 weeks. So that's the cycle speed of the unconstrained. And then the constrained one I ran earlier, I constrained it to 45 hours, and that slowed down because it needed to have less changeover time. So it slowed the wheel down to making those products every 2 weeks, and there's the template. But what I'm going to do now is slow it down a little further and solve the problem for 40 hours and calculate the wheel. So this is solving that problem in the sort of the example I put on the slide. There are 500 and about 15
trillion
zeros of possibilities.
500 million.
It was a lot. It was a large number. So it's going through and it's going to try and find an answer. And I think they're solved in about a minute, something like that. While it's doing that, I'll come back. I think I can. I can't. This algorithm is actually the one that's not taking advantage of the parallel processing as yours. So this algorithm is purely our mathematical algorithm solution to this problem in series. Okay, so it solved that large problem in about a minute. The constraint, the maximum week I wanted to get under was 40 hours, and it's found a solution. I think the maximum week there is 38.94 hours. But to do it, it's slowed the products down so that on average now the products are being made every 4 weeks. So there's, compared to the fastest one, there's almost 4 times less changeovers in that plan, but it's a slower wheel, so there'll be more inventory in the supply chain. And that's got the percentage changeover time in this plan is 18%. I think the unconstrained one was around about 30% or something, 40%. So it's significantly reduced the changeover time as a percentage of the uptime, but it solved the problem. You can visually see the amount of orange has reduced from that plan, so it's mostly runtime now, not changeover time. I won't press the button again for these because it's probably not great. I ran it for a cost optimized one, and as it happened, the answer for that one is coming out as a slower wheel because of the ratio I've got, the relative cost of the changeovers to the cost of the capital, and it's slowed it down. So changeovers in this data, which I've made up, as obviously is a big impact. For the carbon one, when we run it with carbon, this is a typical answer we get for a carbon. It slowed down the frequency of manufacture right down almost to the end. So we say cycle of 8 is our slowest cycle. So it slowed it down to 7.84. So it's making every product just once every 8 weeks. And the reason for that is, and this is the Tata steel example, if you've got inventory, there's a financing cost of inventory, which is taken into account in the cost one, but there isn't really much carbon cost of holding inventory. There isn't a carbon financial penalty, or I haven't got one in anyway. So it tends to want to push in stock, make in slower batches, so you're not getting the waste of product when you're changing over. There isn't really a penalty of the holding the inventory, and it actually also protects against another penalty of part delivery, where you've got a carbon impact of extra logistics. So the carbon optimized supply chain tends to buffer energy use and energy waste by putting in inventory in the supply chain, which is kind of a interesting finding from the project and from the model.
If the input values are correct.
If the input values are correct, yes, obviously, yeah. But that has come out in some of the real model. This is made up data, but it has come out from the modeling with Tata's real data. Okay, so I think that's the template modeling. So over to Christine.
Back on. Hi guys, I'm just going to do a little bit of the inventory modeling and the planning and the analytics. Yeah, okay. So just very briefly, Andy mentioned the analytics platform, and this is the sort of screenshot that you saw in the slide that he presented, which is obviously a sort of anonymized data set, but this is the sort of route of where we would start with any modeling project, is to understand what's going on in the supply chain. So you've obviously got some high level metrics there, looking at forecast accuracy or forecast stability, demand stability, looking at whether the bullwhip is being reduced between demand and production, looking at inventory levels and levels of unused inventory, and crucially that cycle time that Andy was talking about in his demo of the modelling solver. So we've got sort of high level metrics, and then there's the ability to sort of move through the different dashboards so that you get to the next level of detail. So you can look at, you know, volume analytics, look at understanding the Pareto of your products, sales profiles at different levels of detail, whether you want to look at them weekly, monthly, daily, and so on. So just a sort of quick overview of that, because I know that we've not got masses of time available. But so back into the modelling. So Andy was going through the template generation. So once you've got the template, which, as I said, will take into account the cost of inventory in terms of choosing the optimum template, you then, once you've got that template, you want to work out what is the safety stock levels that I want to feed into my system. So in this sort of particular demo that we've got set up, we've run various different templates, and we can compare the inventory output for all of those different scenarios against each other. So you can run different scenarios. In this example, we were looking at how the MOQ affected the cycle times and therefore the corresponding inventory levels. And you can see that, you know, if you decrease the run rates, decrease the MOQs, then obviously the amount of inventory will go down because you can get faster cycles. And we looked at different ways of doing that. So how do we calculate the inventory? If I just sort of go back and look at sort of one particular example. So you can see on the picture here a sort of picture of the network. So we've got a manufacturing site which is providing inventory to 5 different sites. In this particular example, we were just looking at the site 6. And if I click on, basically you have a list of the products, a bit like Andy showed you in the production wheel modelling. So you've got a list of all of the products which are stocked in a particular site, and then you have the ability, using the various filters across the top of the table, to select the products that you want and to select the settings for those products. So typically when we're doing the production wheel modelling, for example, we would want to couple all of the products to the manufacturing site, and that means that their replenishment cycles pick up the production cycle. So we're essentially doing a make and ship model. Equally, you might choose to decouple demand if you wish, which means that you can set replenishment cycles at the tier 1 warehouses which aren't linked to the manufacturing facility. So you could do that in a situation where you can hold stock at your manufacturing facility. You can, if it's coupled, you don't need to do anything around replenishment cycles and replenishment types. But if it's decoupled, you can obviously then choose which products you want to put on a week 1 cycle, which products you want to put on a week 2 cycle, week 3 cycle, and so on. And a service level. Obviously, you need to pick a service level. You can fiddle with your MOQs if you want. Again, in the same way that we do from a modelling point of view, you might want to say, how would the inventory be affected if I changed my MOQs? And obviously that's going to impact in particular your make to order, fixed order quantity products. And you can also change the lead time. So all of this data will sort of come in based upon the master data, which you know, in Tata Steel's case, Claire mentioned, has been a bit of a challenge, but we've got all of that master data in the system so that you can run baseline models, but then you can also vary all of these settings. So you can, you know, select a particular segment of products. You might want to get all of your smooth products, for example, and you might want to put all of those on a, you know, service level of 99, apply that. And they were already on 99, maybe I should put a different one in. 97, apply the parameters, and you'll see that this will update the service levels there. And once you're sort of happy that you've got all of the parameters set up for all of the different products within your network, you can then click the little approve button, and it toddles off into the back end. As you can see, you get a little green message, and it's gone off and it's calculating the safety stock. That might take a little while. So while it does that, I'm going to talk about the planner. So once we've got a template, which defines the cycles for the products, how frequently those products run, but also crucially that sequence within the week, so that you get the minimized changeover times, and you've got the safety stock policies defined for your network, you can then run an operational plan. So to do that, we take in transactional data on a weekly. Well, in Tata Steel's case, we're actually getting the data daily, but we're running the plans on a weekly basis. So we have a starting stock position. We know if there's any stock in transit, any open orders, and any firm planned production going on. And then we've also got the forecast demand coming in. And as Andy said, the planner will then work out, based on the production wheels, it will come up with an unconstrained plan, putting all of the products in the weeks where it should be made to meet the template and also the demand requirements. And then it runs a constraining algorithm, bringing typically product forwards to pre-build stock if there's a production constraint. So if I just click on one of these plans, maybe I'll show you how we set up a plan first. So to set up a plan, you would choose your start week. I think this demo data is quite old, so I'll have to go back in time a little bit. But you set a week and you can give it a description. And you choose what period you want to run your plan for. So for Tata Steel, we're usually running a relatively short horizon, sort of 20 weeks or so on. But for some of our FMCG customers, you'd be running a much longer plan horizon, you know, typically 12 to 18 months out. So you can put your plan horizon in, and then you can also say what period you want to constrain, which is typically less than the full plan horizon. So you can run a plan for a full sort of 50 or 52 weeks, but you might only want to constrain the first 25 weeks. But you do want that full visibility of what's going on in weeks 25 through to 50, so that you are aware if there's any big promotions coming up, for example, that might require you to take action sooner rather than later. So you put a constraining horizon in, so I'll just put 20 in. You can then go through and you select which sites. Very simple data set we've got here. We've just got one site and it's just got one asset at it as well. And then you click OK. And then you click run. It'll go off and run something. But while that's doing that, I will go into my little pre-run plan, as in Blue Peter. Here's one I prepared earlier. So typically you would see the list of all of the different sites that you've run a plan for and all of the work centres. You would then be able to click on those and get an overview of what's going on the plan. So tricky on my tiny laptop screen, but basically what you've got is 4 tiles, bit of sort of master data around the plan that you've generated, and then you've got sort of 3 views, one which is looking at the capacity usage, one which is looking at the amount of stock build that you've got, and the other one which is looking at any stock projection exceptions that you've got. And the idea is that those give you an overview of your plan, and then you can then click on each of the tiles to get through to the next level of detail. So if I just do that now, just checking the time, how long? A couple of minutes. Yeah. So here we can see by week, the purple line is how much capacity is available. In the purple weeks, we only need the amount of capacity that's available. In the grey weeks, we're under the capacity that's available, and in any of the orange weeks, they are weeks which are over capacity. So in this case, it hasn't been able to fully solve the plan. The reason I've got a very big bar here in the first week is, I think Andy may have mentioned bow wave solving. So because this is a dummy data set, we don't actually have a proper starting stock position loaded for the data. So it's basically trying to build all of the safety stock and all of the demand for the next cycle. But you can go into this plan and you can edit the capacity data. So I could say in that first week, for example, instead of having 53 hours, I might just want to choose weeks 1, 2, and 3. Choose the weeks. Two, I haven't got 2. I could do a bulk update. And I can increase the capacity in those weeks to 150 hours, for example. Apply the change, and then I can update the plan. And in the background, it'll just update. It will run my new little plan. It shouldn't take too long. Just adding the hours in. Hopefully, shouldn't take too long.
Your other things were. Your inventory run.
My inventory might run in the meantime. Yes, there you go. Yeah. Oh no, it's not. It's still calculating. 104 days. Yeah, okay, that might take a while. It's always the way when I tested this yesterday, it took seconds.
Is it because you're in 2 weeks apart?
Possibly. Yeah. Go back and perhaps look at one of the other ones just to got one. Still running. Unfortunately, as I think we probably should move on to the Q&A session.
Yeah,
Should we?
fine.
So, but basically, you can see that you've got an interactive planning board that the planners can look at the plan. They can take decisions based on the information that they've seen. If they need to add it in extra shifts, if they believe that there's too much of a stock build going on, they can choose to override the plan, reduce the planned quantities and so on, and come up with a plan that they're happy with, and then approve it, and then it'll get sent off to whatever their source scheduling system might be. Okay.
This has probably been one of the best, if not the best project that I've had the pleasure of being involved in. I think it demonstrates a number of things. One, I suppose, the extent to which now that we're in a more data-driven age, but also that we have the analytic capability, the computing power to be able to do analytical activities in parallel that previously would have been in series, and so therefore would have taken too long to have been able to give us as results, means that we really do, I think, have the opportunities to be precisely right. Whereas I can remember being told in my career previously, Jan, it's better that you actually do something and make a decision that's roughly right rather than being precisely wrong. But I do think we're entering this really exciting time. And more to the point, I think it's really important that we start to find ways to bring carbon into the equation. I think lots of people talk about it. We've got basic ways of being able to begin to build it in. I think there's reporting around scope 1, scope 2, scope 3, but actually to start to use it dynamically, to start to maybe use it to make slightly different optimized decisions across the end-to-end supply chain. I think that this platform is really a step in that in that direction. And so from a Loughborough perspective, my heartfelt thanks to the SupplyVue team, to the Tata Steel team, also to Carbon Chain, to Rodrigo, who now works for Siemens Healthcare, but without whom he was a sort of glue that held the project together, being very, very flexible in his approach to adapt to, I suppose, what was required by the project to actually make it a success. And as they alluded to, a lot of that was more around education than perhaps we'd originally thought. And I very much hope that we will continue to collaborate together, find new sources of funding. And I very much hope that Tata Steel goes on to have many more customers because of the very ethical and responsible way in which they operate. SupplyVue sells lots of CarbonVue, and that those of you who wish to pursue this further, maybe more from an academic perspective, take the time to reach out to Loughborough. Those of you who are more academic, please do also reach out to the Interact Network, and there's many more actionable insights that we can share with you about how we may digitise to create that digital future that we want. So again, my sincere thanks to everybody, and have a lovely afternoon.